So I was pondering how to make a 3D array out of 2D arrays, and I came up with the best method that I could think of. And basically all we're going to do is create a structure, which each of the structure's items going to have one X and then an array of Y and an array of Z. And then in our actual blueprint, we'll create an array of X. So what that'll mean is for every X coordinate, we have an array of Y, and then an equivalent array of Z, which will give us that three-dimensional array. And then with the array of the structure, it'll then give us an array of X. So each X has an array of Y. We have an array of X, meaning we add the extra dimension to the structure. Then within our blueprint, I've created a couple different functions to access data. This is just super basic at this point. I created a print, which is very basic. We go through, we go ahead and for each X, we then pass to our Y array and try to get every Y, and then we basically just add that to a string with an append. And then at the very end, we print it. That'll give us every X in order and then every Y in order with each X. The next function I made was a get a block at that location. This allows me to look through the array and get some of the data back out. Unfortunately, since there's not a proper 3D array, you're stuck coming up with your own access functions. So all this does is it looks through our X array, tries to find a matching X value. If it does, then it'll move up to our Y array and try to find a matching Y value. If it finds both, then it'll then grab our Z value and pass it in a return for the function. If it doesn't, it will return false with a value of 0. And then the most complex function is a add to the array function. And so it looks kind of complex. There's only 4 main parts to it, maybe 5. And then the yellow block's just diagnostics to kind of see what's going on. So all it does is it starts out and it looks to see, does the X already exist in your array? If it does, then it's going to move up into our Y section and say, does the Y already exist? If it already exists, we just set the Z element and we just leave, because there's no point in adding it to an array, it already exists. If it does not exist, it'll then check each time to see if our element that we're pulling out of the Y array is bigger than the element that we're looking for. This is super important because what it'll do is every time we add a Y to our array, it'll insert it sooner into the array, allowing it to stay in order. That will stop you from having to sort the array later, because as the array scales, that'll become a bigger and bigger task, and that'd just be a nightmare to deal with. So this will keep all of your Ys in order, and then if it never finds a bigger one, it'll go down the completed, and it'll just tack it on the end. And all we're doing is making a structure. We're pulling our broken... we have to save this broken structure into a temporary variable. Unfortunately, we can't write to the broken strut, or it doesn't change anything. So we write it to a temporary, and then when we add it to our array, we just make a new one and call those temporary values. And then we add that array, or we set the array in our structure. Adding to the end, we're doing the same concept. We're just adding to our temporary variables, and then we build a structure piece around that and then set it. Super easy peasy. Same thing with our X, just a little more simplified. If we find an X value in our array, and the X value we're passing is not equivalent, we will then add it to our array. Super easy peasy. We just make 2 arrays, tack it in there, because if there's no X, then there's no associated Ys, because of just how the structure's set up. And lastly, if it does not find a bigger value, it's going to tack it onto the end. Same concept, but instead of inserting it, we're just going to add it. So that'll allow us to build an array dynamically, and it'll keep everything in order. So later on the line, you could check the completeness of your array, and then later on, I'll probably implement something that'll allow me to parse through the array more quickly. And instead of looking single digit by single digit, it'll probably check row by row, and that'll allow me to not have to look through the entire array for each and every index. So just as a quick test, what I'm going to do is I'm going to go ahead and set 20 random values. We're going to have X values between -5 and -3, and then y values between -100 and +100. And we'll see that all these will be kept in order. -5 only counts up in the y's. Same here. This also does work with negative values. So you'll see as we go over to the next number, we'll see the negative numbers first, and then we'll see the positive later. That keeps it nice and orderly. And then same thing if I bypass that loop. Instead, we set a value. We'll say like 20. We'll say 19. And we'll set a value of 23. Keeps everything different. From there, we'll call our getAtLocation, and we'll look for that 2019. And so what will happen is we need a structure. Call it. We have to print. Yes. That's what this is for. So what this is going to do is it's just going to make a quick statement. It'll basically say, do I see a block? And if I do, what's the value? If I don't, it'll print 0 based on how the get function set up. If we call it in, we'll see there is a block there and its value is 23. If it doesn't exist in the array, it will return false because the get block at location will not execute a valid outcome, and it'll just return false. Anyway, hope that helped.